Good afternoon, everyone. So our lesson for today is on exponential and logarithmic function. And in this lesson, we'll basically look at an exponential function. So to start with, let's look at the definition of an exponential function. What is an exponential function? So an exponential function with the base a is a function of the form f of x is the function of the form f of x which is equals to n x like that. So this a that you are seeing here is our base and x is our exponent. So few things that we need to take note. So if we have f of x, which is equals to a to the power x. So this function can either increase or decrease depending with the nature of our a. So if a here, which is our base, is greater than 1, we are expected to have a function that is increasing in nature. Let's take, for instance, we have f of x, which is equals to 2 to the power x. So in that case, the value of a is equals to 2, and 2 is actually greater than 1. So we said once a is greater than 1, we expected to have a function that is increasing. So this is the function that we are likely to have. So sketching the graph of this, you need to know the asymptote. Because the asymptote is the line, it's the one that is going to give you guide to say, is this function, is the graph that you're going to draw, is it going to be above this horizontal asymptote, or is it going to be below the horizontal asymptote? Sure. So how do we know, how do we find, or rather, the horizontal asymptote? So the horizontal asymptote is just that constant term. If we write the function like this, 2x, or f of x is equals to 2x like that, and there is this number here. So in this case, it's a 0. So this constant value that we have is always our horizontal asymptote, and it's given by the equation y equals to 0. So this is our horizontal asymptote. This line is the line y equals to 0. So now, we need to know now, is this graph going to be above or below? So we look at the coefficient of this a here. Since it's positive, we expect our graph to be above. And you can find where it is cutting along the y-axis, which is the y-intercept, by placing a 0 in this function. If the x is 0, what is going to be the corresponding value of y, which is going to be 1. So when you look at this function, this is how the graph of this is going to be when it is increasing. When a is positive, this is what we are expected to have. Now let's move at the other part. Now, if f of 8 is equals to a to the power x, and if this a here is between 0 and 1, but not 0, but also not what? 1. If at all we get a number, let's say for example, we have 1/5, 1/3, 1/, those values are falling under this set. So if a is between 0 and 1, we're expected to have a function that is decreasing. Let's take, for example, you have f of x. F of x is equals to, let's say, 1/2 to the power x like that. So when you look at this part critically, this value here, 1/2, is the value of a. And this a is between 0 and 1, because 1/2 is simply 0.5. So it's between 0 and 1. So in this case, we're expected to have a graph that is decreasing, meaning that as we are moving to our right, as the values of x are increasing, the function is what? Decreasing. So we are expected to have something like this. So even in that case, we are still seeing our horizontal asymptote being y equals to 0. So this is still our horizontal asymptote. And now, since it is decreasing, as the values of x are increasing, so the function is going to be something like that. So, like that. So just have to know the intercept there. Where is it cutting along the y-axis? So it's cutting at 1. So when x is 0, plug a 0 there, you're going to have half to the power 0, and half to the power 0 is 1. So that's what we are going to have there. So this is about our function, to say an exponential function can be an exponential growth or an exponential decay. So in this case, we have seen an example. We've seen two examples of an exponential function that is increasing and an exponential function that is decreasing. So let's go back now to our examples. So our example here, in our example here, we're required to sketch the graph of the following. F of x equals to 3 to the power x, f of x is equals to negative 3 to the power x, and f of x, etc. So let's start with the first case. So the first case here, which is f of x is equals to, f of x is equals to 3 to the power x. So let me mention one thing. Exponential function, the domain for an exponential function is actually running from negative infinity up to positive infinity. As for the range of an exponential function, is dependent upon the horizontal asymptote. So if the horizontal asymptote is the maximum, or if at all the graph is below the horizontal asymptote, we are saying the horizontal asymptote is going to be our maximum. So it will be from that horizontal, it will be from negative infinity up to that horizontal asymptote. And that horizontal asymptote is not supposed to be included because the graph is not going to cut the horizontal asymptote. So it has to be open. And if at all the graph is above the horizontal asymptote, it simply means that the minimum value there is going to be the horizontal asymptote, but the horizontal asymptote is not supposed to be included also in the interval. It has to be open at horizontal up to positive infinity. So let's start with this question. F of x is equals to 3 to the power x. So in this case, our horizontal asymptote here is equals to y equals to 0. That's our horizontal asymptote. Sorry for that. Y equals to 0. So y equals to 0. And then we come up with few values. And then the value of a actually is very important. The value of a is equals to 3. So already a is 3, which is greater than 1. We're expected to have a function that is increasing in nature. And then we look at now we can move to the sketching part. So always start with the x or y plane. So we have the x there, we have our y and our 0 there. So what is we start with the horizontal asymptote. This is our line of operation. Now that we know our horizontal asymptote, number 2, we need to know, is the graph going to be above this horizontal asymptote, or is the graph going to be below the horizontal asymptote? So what is going to give the guide about that? The coefficient here. When you look at the coefficient here, it's positive. It's a positive value. So since it's a positive, we expect our graph to be above the horizontal asymptote. But if it is negative here, we expect the graph to be below the horizontal asymptote. So now that we not say it is going to be above, and the value of a here is 3, the function is what? Increasing. Like that. So it will be something like this. As we are moving to our right, the graph will start increasing. So that's what we are expected to have. So we need to know where it is cutting there. We can just come up with a small table of values. So you have x, you have y, like that. So when x is 0, when x is 0, what is going to be the value of y? So when we plug 0 there, we'll have 3 to the power 0, and 3 to the power 0 is 1. So in short, our y-intercept is it's cutting at y equals to 1. So the coordinates at y-intercept will be 0, 1. So I'll just put a number there, say it is cutting there, y. So we can even include some other values so that you can see. But for example, that is the first value that we have. And then if you pick another value, let's say for example, it's easy to use a 0 and a 1. The values of x, if you use 0 and 1, it becomes easy. So when you put a 0 there, what is x? Now we put what? We put a 1. So when x is 1, we are going to have 3 to the power 1, which is 3. So we have 0, 1, so 1 is here, and 3 is somewhere there. So that is 3 there. So you're seeing these two values are more than enough to give you a guide to say your graph will be like that. And it's moving from negative infinity, as you can see, it's moving from negative infinity up to positive infinity. That is our domain. So when you look at the range now, the range of values will start from this line here going upwards. So our range in this case is going to be all real values from 0 up to positive infinity, but 0 is not included because this is the asymptote. This graph will never touch this horizontal asymptote. So that's the first part. We move now to the second part. The second part, which is the f of x, which is equals to negative 3x. So this graph here, this function that we have, is just coming from this function that we're just from sketching, f of x, which is equals to 3x. That's where it's coming from. So this negative that we are seeing here is just telling us that the graph here, this graph has to be reflected. It has to be reflected about the horizontal asymptote. So if at all the graph that we had was like this, it was like that, that was the graph that we had. That is x, y, and x. That is what we had. So this graph here, it's at 1 there. It has to be reflected about this line here. So if that one here, when we reflect this, meaning that we expect to have a graph of this nature. To be a graph of this nature, that's what we are expected to have. So it's just a reflection. So that one to be down here, so it will be at negative 1. So that's a graph of this. This is just a reflection of this. So having said that, let's look at it now independently. At the graph independently, because we're not going to be comparing each and every time. So this graph here, number 1, let's come on. Number 1, what is the horizontal asymptote? Y is equals to 0. That's our horizontal asymptote. Number 2, what is the value of A? The value of A is still 3. So the value of A is the one that is to the power x. So it is this. That is the value of what? That is the value of A. So the value of A is the value of A is equals to 3. And then secondly, this negative here is just saying this graph has to be reflected about this line. So let's sketch now our graph. So we have this. Our horizontal asymptote is this line. Y equals to 0. Y is equals to 0. And then y like that, and x. So remember, this a is equals to 3. It's an increasing function that has to be reflected. So an increasing function was up, but now we just have to reflect it downwards like that. And the value there, you can also come up with a table of values, x and y. And then when x is 0, y is 1. Y is negative 1, sorry. Y is negative 1. So it's cutting there. Let's see. Y equals to negative 1. You can pick another value and do a comparison. So that's about this graph here. Let's move to the other part, the third one. Third one is f of x, which is equals to 3, which is equals to, it's 1 over 3, 1 over 3 to the power x. So this 1 over 3 to the power x can be written as 3 to the power negative x. So when you see something like this, when you just see something like this, just not say this is the same as 1 over 3. So when you see 1 over 3, just not say it's the same as this part which is here. So let's look at a few things. What is the value of A? The value of A here is equals to this. A has to be to the power x, not to the power negative x. So if you get something like, let's say 3 negative x plus 4, just not say A is not 3 here. A is not 3. The value of A that is to the power x. So this piece here, when you rewrite it, it is 3 to the power negative x minus 4 like that. So meaning that it's 1 over 3 to the power x minus 4. So meaning that this part here, 1 over 3 is your A. So don't get confused when you see this number and you just pick it to say that is your A. No, the A is always that value that is the power what? X, not the power negative x. So you have to write it like this. So in our case, the value of A is 1 over 3. And this 1 over 3 is actually between 0 and 1. So since A is between 0 and 1, we're expected to have a decreasing function. And then 2, what is our horizontal asymptote? Y equals to, there's a plus constant which is 0 there. Y is equals to 0. Our domain is always from negative infinity to positive infinity. And then our range, we'll be able to see it from the graph. So let me just wrap this here. So from what I've just said, let's look at this. So just do this. It's a decreasing function. This is our horizontal asymptote. Number 1, that is x, and that is 0 there, and that is y. So we have two parts. There's this upper part and the below part. So is our function going to be, is our graph going to be above the horizontal, or is going to be below the horizontal? We go back to this function here. The coefficient of A here is positive, meaning that our graph is going to be above the horizontal asymptote. Number 2, we have this A, which is between 0 and 1. So the graph is decreasing. So as we are moving to the right side, the values of x will be decreasing, like that. So it's something like that. So I beg your pardon. Let's remove that. Okay. So our graph is going to be something like this. Yeah, so it's not going to touch the y-axis. So we just need to know that point which is there. So you can just give yourself 2 values, 2 points, so that you can see what is happening. So most it's better to go with a 0 and a 1. It becomes easier to use. So when you plug a 0 there where there's x, we're expected to have this to the power 0, which is 1. So when x is 0, the value is 1. That's why we are saying the intercept here is at 1, the y-intercept. And then 2, we can just put a 1 there. So when x is 1 here, the value of y is 1 over 3. So when you have 1 there, 1, the value there, down there, it's 1 over 3 like that. So you have this point and you have that point and that point. So already these 2 points are even telling something to say the function is what? Decreasing. So let's move to the last part. The last part is the reflection. Now, the reflection of the same graph, you have negative 1/3 to the power negative x, that's to the power x, sorry, to the power x, like that. So this is the same as saying negative, okay, this is the same as -3 to the power negative x. One and the same. So if you see something like this, do not rush and say the value of a is 3. No, then only say the value of a upon this power being just x, not negative x. So like this is 1/3 to the power x. This implies that the value of a is 1/3. So value of a is 1/3, and it's actually between 0 and 1. So the function here is a decreasing function. Decreasing function. Now, number 2, is it going to be above or below the horizontal asymptote? It is going to be below the horizontal asymptote because of the negative. So below horizontal asymptote, below the horizontal asymptote. And then what else do we need to know? What is the horizontal asymptote itself? The horizontal asymptote is y equals to 0. Y equals to 0. So if we are to sketch this, something like this, that is our x and that is our y. So that is the equation of our asymptote, which is y equals to 0. So since this function is decreasing and we are saying it has to be, this is just a reflection of 3 to the power negative x. So it has to be below the horizontal asymptote. So it just be something like this. That's how it's going to be like. So that point there is -1. So if you are not sure about that, the best is put even 3 values so that you can see the points. So when x is 0, when you plug a 0 here, this is going to be 1/3 to the power, which is going to be 1, and 1 multiplied by negative, it will give you as -1. That's the -1 that we have there. That's our first coordinate. And then the other coordinate here, we can say when x is equals to, you can just say when x is equals to